Swayam Prabha. Digital India. Educated India.
Hello everyone, I am Dr. Rose, Assistant Professor, Department of Anatomy, Government Medical College, Thrissur. In this session, we will be dealing with the changes happening to the embryo from 4th week to 8th week of intrauterine period. Before moving on to the topic proper, let me put you a clinical scenario. A 28-year-old tribal lady came to the gynecology department with history of missed periods. So, whenever a case comes to you with a history of missed period, what you will be doing? You will be doing a pregnancy test. And in this case, it came out as positive. Since she was not remembering her last menstrual period, the doctor decided to do a USG scan. And when they did the USG scan, the result was a bit negative. That means the doctor could find out some malformations for the embryo. So, actually it is not embryo, she came at 6 months of gestational period. So, the doctor could find out some malformations for the developing fetus. And this was the case, it was a case of anencephaly, which means failure of closure of the neural tube in the cranial region. In this case, the brain will fail to develop, and the doctor since the doctor diagnosed prenatally, he asked her to terminate the pregnancy. So, if you want to understand the details of anencephaly, how this happened, you need to know what are the changes happening to the developing embryo from 4th week to 8th week of intrauterine period. So, in this session, we will be dealing with the main events occurring in the 4th week under the following headings: the differentiation of the 3 germ layers, the ectoderm, endoderm and mesoderm, the formation of somites, the formation of folds of the embryo. We know that there are 2 types of foldings for the embryo. One is cephalocaudal folding and the other one is lateral folding. We will be seeing the details of the foldings, and also we will be seeing the applied aspects. So, let us see the differentiation of intraembryonic mesoderm. We have already seen that a germ disc consists of 3 layers: the ectoderm, endoderm and intraembryonic mesoderm. So, let us see what are the changes happening to the intraembryonic mesoderm, that is the differentiation of intraembryonic mesoderm. So, the intraembryonic mesoderm is differentiated as the first one, the paraxial mesoderm. What do you mean by the paraxial mesoderm? So, this is ectoderm, this is endoderm, and in between you have the mesoderm. Since it is within the embryo, you call this mesoderm as intraembryonic mesoderm. And you can see the formation of notochord in the middle. So, the mesoderm lying just next to the notochord, that is what is meant by paraxial. Since the notochord is forming the axis of the embryo, the mesoderm lying on each side of the notochord, you call it as paraxial mesoderm. And this is actually the neural plate over the notochord. So, this paraxial mesoderm will be lying under the neural plate as well. After that, you have the intermediate mesoderm. So, paraxial will be lying on either side of the notochord. Next to that, you have the intermediate mesoderm, which is marked as number 2. And lateral to that, you have the lateral plate mesoderm, that is the periphery of the germ disc, which is continuous with the extraembryonic mesoderm. We have already seen how the extraembryonic mesoderm is formed, and the extraembryonic mesoderm, as the term implies, it is lying outside the embryo, the embryo proper. So, this intraembryonic mesoderm at the periphery will be continuous with the extraembryonic mesoderm. So, this is a schematic representation. This is a view this is how it will look like when you look from above after removing the amniotic membrane. So, you can see this is the cephalic end or the cranial end, and this is the caudal end. You can see 2 circles. These are the precaudal plate and the cloacal membrane. So, at the precaudal plate you have the buccopharyngeal membrane, and at the caudal end you have the cloacal membrane. In between you can see that the intraembryonic mesoderm is getting differentiated as the paraxial mesoderm. This black colored region is the notochord. Here we have not shown the ectodermal layer, we are just dealing with the intraembryonic mesoderm layer. So, the ectoderm layer is also removed to show the differentiation of the intraembryonic mesoderm. So, in the middle you can see the notochord, on either side you can see the paraxial mesoderm, and you can see the intermediate mesoderm which is marked as number 2 on either side, and the remaining intermediate mesoderm or the intraembryonic mesoderm is known as lateral plate mesoderm. So, this is the differentiation of intraembryonic mesoderm, the mesoderm within the embryo. So, again you have the notochord in the midline. On either side of the notochord you have the paraxial mesoderm, just lateral to it you have the intermediate mesoderm, and the remaining intraembryonic mesoderm is known as lateral plate mesoderm. So, these are the 3 different types of mesoderm you get from the intraembryonic mesoderm. Now, let us see what are the features of each mesoderm in particular. First one is paraxial mesoderm. We have already mentioned that it is lying on either side of the notochord, and this will be extending from the primitive streak which is seen at the caudal end to the precaudal plate which is seen at the cranial end. That is the extent of the paraxial mesoderm. So, paraxial mesoderm extends from the primitive streak which is here to the precaudal plate at the cranial end. Now, what is the fate of the paraxial mesoderm, or what are the derivatives of paraxial mesoderm? If you consider the otic capsule here, pre-otic somites are the derivatives of the paraxial mesoderm, and they give rise to the formation of extrinsic muscles of the eye, and the remaining somites are known as post-otic somites. They are segmented. You can see many segments in the somites, and they are known as post-otic somites, and they are segmented and they are known as somites and somitomeres. Actually, these somites are cubical blocks. You can see they are arranged in the form of cubes. They are cubical blocks, and they develop between 20th and 30th day of intrauterine period. So, these are the derivatives of the paraxial mesoderm. And actually, the age of the embryo may be referred to 3 periods based on the development of somite. So, somite, the formation of somite is considered as a referral point. So, if you consider that the embryo is having somite, you can divide the period of the embryo into a period where the somite is not formed, a period where somite is formed, and period after the formation of somite. So, that means the first one is known as pre-somite period, that means before the formation of somite, that is between 15th and 20th day of intrauterine period. Then you have the somite period. Somite period extends from 20th to 30th day of intrauterine period. So, this you can see here the formation of somites. This is the neural plate which will later forms the neural tube, and this is the ectodermal layer, and this is the mesodermal layer. So, the paraxial mesoderm will be giving rise to somites from 20th to 30th day of intrauterine period, and the next period is known as post-somite period, that is after the formation of somite from paraxial mesoderm. So, that can be roughly considered as after 30 days of intrauterine period. Now, let us see the details of somites, or what do you mean by somites? So, we have seen that the somite is actually derived from the paraxial mesoderm, and the somite period is roughly said as 4th week of intrauterine period. And we get roughly 44 pairs of somites during the development. Actually, 4 to 5 pairs of occipital somites are giving rise to the formation of skull. What are the parts of somites? A single somite consists of a dorsolateral portion as well as a ventromedial portion. You can see, if you consider the entire thing as somite, you can see the neural tube here you can see the notochord here. So, the paraxial mesoderm was lying on either side of the notochord, and this paraxial mesoderm is differentiating as segmented somites. Each somite consists of a dorsolateral, a major portion is contributed by the dorsolateral portion, and you can get a ventromedial portion as well. This is the notochord, this is the neural tube. On either side of the notochord, you get somites, cubical blocks. Now, what do you mean by the dorsolateral portion, or what are the derivatives of the dorsolateral portion? Dorsolateral portion is otherwise known as dermomyotome. Dermomyotome means it consists of a lateral dermal plate. So, lateral dermal plate means it gives rise to, as the word implies, it gives rise to dermis of skin and subcutaneous tissue. These are the derivatives of the lateral dermal plate, dermis of the skin and subcutaneous tissue, and medial muscle plate. So, what are the derivatives of muscle plate of a somite? The skeletal muscle, tongue and diaphragm. So, these are the derivatives of the medial muscle plate of a somite. So, the lateral dermal plate and medial muscle plate together forms the dermomyotome, which is actually seen on the dorsolateral aspect of the somite. So, this is the neural tube. You have the notochord here. Here you have the somite, which is getting differentiated into a dorsolateral portion and a ventromedial portion. The dorsolateral portion is forming the dermal plate and muscle plate, and the ventromedial portion will be forming the sclerotome. So, ventromedial portion is otherwise known as sclerotome. Dorsolateral portion was known as dermomyotome, a combination of dermal plate and muscle plate, but the ventromedial portion is purely giving rise to sclerotome. So, what is the fate of sclerotome? Sclerotome is actually giving rise to the formation of vertebral column and ribs. You have the notochord in the middle. So, this is actually lying more closer to the notochord. The sclerotome component is lying more closer to the notochord, and it will wrap the notochord in order to form the vertebral column, and it will spread outwards to form the ribs. So, these are the two main things which are developed from the sclerotome component of the somite. Then we will come to the intermediate mesoderm. So, the intraembryonic mesoderm from medial to lateral. First we have the paraxial mesoderm, which was lying on either side of the notochord. We said the details of the paraxial mesoderm as the somites are developed from it. Now we have the intermediate mesoderm just lying lateral to the paraxial mesoderm. This is the notochord once again. You have the paraxial mesoderm on either side, and this violet colored thing is known as the intermediate mesoderm. This is actually a longitudinal strip of mesoderm, and this is actually connecting the paraxial and lateral plate mesoderm. If you consider the intraembryonic mesoderm as a strip, this is actually lying between the paraxial mesoderm medially and the lateral plate mesoderm laterally. So, this is acting as a connector, a longitudinal strip lying between the paraxial mesoderm and the lateral plate mesoderm. This is actually again segmented in the upper part, and the unsegmented portion in the lower part will be giving rise to the nephrogenic cord. So, what are the derivatives of the intermediate mesoderm? So, the intermediate mesoderm in future will be giving rise to the kidneys, the formation of kidneys and the 6 glands. Now, we will move on to the lateral plate mesoderm. So, if you consider the intraembryonic mesoderm, we just discussed about the paraxial and intermediate. Both are roughly longitudinal collection of mesodermal cells, whereas the remaining mesoderm, which is occupying the entire germ disc, you call it as lateral plate mesoderm, and they will be lying laterally. They are usually unsegmented, and they are derived from the primitive streak. So, the primitive streak is actually giving rise to the intraembryonic mesodermal layer. So, the lateral plate mesoderm will be obviously coming from the primitive streak. This lateral plate mesoderm continues cranially. It won't be going in between the ectoderm and endoderm at the precaudal plate. It will be just winding around, and it will be going cranially, and this will be continuous with the pericardial bar. Pericardial bar is again a mesodermal layer which is seen in the form of an inverted U cranial to the precaudal plate. So, this lateral plate mesoderm will be continuous with the pericardial bar cephalic to the buccopharyngeal membrane. It is the buccopharyngeal membrane which you get at the region of the precaudal plate. So, the lateral plate mesoderm, as it moves cranially, it will be continuous with the pericardial bar which is seen cephalic to the buccopharyngeal membrane. So, the pericardial bar will be in the form of an inverted U. Now, let us see the formation of intraembryonic coelom. So, till now we have discussed about the formation of ectoderm, endoderm, the formation of intraembryonic mesoderm, and what is the fate of intraembryonic mesoderm. Now, we are moving on to the formation of intraembryonic coelom, the cavities within the intraembryonic mesoderm. So, initially in the lateral plate mesoderm, you will be finding very small clefts, and in the later period they will coalesce to form a single cavity. That single cavity is an inverted, again U-shaped cavity, large U-shaped cavity which is seen within the lateral plate mesoderm. This U-shaped cavity, you can see it here, this U-shaped cavity is known as the intraembryonic coelom. Now, intraembryonic coelom, what is the fate of intraembryonic coelom? Why this intraembryonic coelom is formed? This intraembryonic coelom, as soon as it is formed, will be communicating with the extraembryonic coelom. When we discussed about the intraembryonic mesoderm, we mentioned that towards the periphery of the germ disc, it is actually continuing with the, it is continuous with the extraembryonic mesoderm. Similarly, the cavity formed within the intraembryonic mesoderm, that is the intraembryonic coelom, as soon as it is formed, it will try to make a continuity with the coelom found outside the embryo, that is the extraembryonic coelom. So, have you ever thought why this continuity is maintained between the extraembryonic coelom and intraembryonic coelom? This is in order to get nourishment from the extraembryonic coelomic cavity for the embryo. So, the embryo will try to grab all possible options of nourishment. So, this communication between the intraembryonic and extraembryonic coelom will provide nourishment for the embryo. Now, what is the fate of this intraembryonic coelom? Why you want an intraembryonic coelom be formed? This intraembryonic coelom is actually giving rise to our future pericardial cavity, our future pleural cavity and peritoneal cavity. So, ultimately all the important cavities within the body, the pericardial cavity surrounding the heart, the pleural cavity surrounding the lungs and the peritoneal cavity covering the abdominal organs, all these major cavities are derived from the intraembryonic coelom, a cavity within the intraembryonic mesoderm. Suppose if you are going to take a section here, this view is actually after removing the amniotic membrane, and this is as if you are looking from above. Now, what we are going to do is, you are just going to take a section like this. This is actually the coronal section. If you just take a section like this, let us see what are the features which you will be seeing. So, this is the ectodermal layer, this blue colored one, and you can see this as endodermal layer. In between you can see the intraembryonic mesoderm. So, the cavity above the ectoderm will be the amniotic cavity, the cavity below the endoderm you can call it as yolk sac, and this region is actually the lateral plate mesoderm where you got the development of intraembryonic coelom. This is actually wide open. Why this is wide open means laterally it is communicating with the extraembryonic coelom. Later what happens is, you can see that the amniotic cavity is expanding, and as it expands laterally, it is actually folding at the lateral aspect and it is coming closer to the yolk sac. So, you can see that this amniotic cavity, as it enlarges, it folds the embryo laterally and it comes closer to the yolk sac, so that this intraembryonic coelom is actually now made into a shape of a tube. So, let us see how this tube will look like. So, the derivatives of intraembryonic coelom. So, this is actually a U-shaped tube, and what are the derivatives? In the cephalic region, this will be giving rise to the formation of pericardial cavity. In between you can see the pleural cavities being formed, and in the caudal region or more towards the caudal region you have the formation of peritoneal cavity. So, this is how all these three cavities are formed from the intraembryonic coelom. So, this is again a schematic representation. We have just taken out the intraembryonic coelomic portion and we are looking at it. So, the cephalic region, you have the pericardial cavity, after that you have the pleural cavity, and then you have the peritoneal cavity. These are the three major cavities of the body, and we can see that here all these cavities are closed. Till now we mentioned it as a single cavity, and how these cavities got closed? These are closed by membranes developing between the cavities. So, here you can call it as pleuropericardial membrane. Pleuropericardial membrane is the membrane which separates the pericardial cavity from pleural cavity. Similarly, you can see another membrane that is known as pleuroperitoneal membrane, that will be separating the pleural cavity from peritoneal cavity. So, that is known as pleuroperitoneal membrane. And at the caudal end you can see there are two peritoneal cavities, but in adults you know that it is seen as a single peritoneal cavity. Pericardial cavity we have one in number, pleural cavities we have two in number because we have two lungs on either side, and that will be covered by two separate pleural cavities. But again peritoneal cavity is only one in number. So, why in the initial period you have two? So, this is actually fusing in the later period of development, and this will be seen as a single peritoneal cavity. And in the pleural cavity you have the lungs which is invaginating into the pleural cavity, and in the cephalic region you have the heart which is invaginating into the pericardial cavity. So, I would like to add one point here. Most of us think like heart is inside the pericardial cavity, lungs is inside the pleural cavity. It is not like that. The heart is just invaginating into the pericardial cavity, lungs is just invaginating into the pleural cavity. It is not going and sitting inside these cavities. So, the cavities are closed sacs which are just wrapping the heart, wrapping the lungs and wrapping the abdominal organs. No structure is inside these cavities. And whenever, have you ever thought what will happen if these membranes are not formed? Whenever these membranes are not formed, the structures from each cavity will be herniating to the other cavity. So, the intraembryonic coelom actually splits. As the intraembryonic coelom is formed within the lateral plate mesoderm, it is actually splitting the intraembryonic mesoderm into two layers. That is, one is somatopleuric. As the term implies, what do you mean by somato? It will be lying closer to the ectoderm. This blue colored is ectoderm. So, the part of the mesoderm lying closer to the ectoderm you call it as somatopleuric. Here you get the intraembryonic coelom. So, previously the mesoderm here was just a band of mesodermal cells. Since this cavity is formed, this band of cells got split up into a part lying closer to the ectoderm and a part lying closer to the endoderm. So, the part lying closer to the ectoderm you call it as somatopleuric. Similarly, a part lying closer to the endoderm you call it as splanchnic. So, let us see what are the derivatives of somatopleuric or parietal intraembryonic mesoderm. So, somatopleuric is otherwise known as parietal part of intraembryonic mesoderm. We have already mentioned that the intraembryonic coelom is actually splitting the mesoderm into two layers based on whether the mesoderm is lying closer to the ectoderm or whether the mesoderm is lying closer to the endoderm. If it is lying closer to the ectoderm, you call it as somatopleuric. And what are the derivatives of somatopleuric mesoderm? This is actually giving rise to the parietal layer of all these cavities which we have mentioned right now. It is forming the parietal layer of peritoneal cavity, pleural cavity and pericardial sac. Parietal means lying closer to the body cavity. So, this is the ectoderm. So, this mesoderm will be lying closer to the ectoderm, and these are the derivatives of this layer, the somatopleuric intraembryonic mesoderm, that is the parietal layer of the peritoneal, pleural and pericardial sac. This layer is also giving rise to dermis. Since the ectoderm is giving rise to epidermis, this layer is actually lying just closer to the ectoderm. So, what will be the layer seen just closer to the skin? That will be the dermis. It is also giving rise to the skeletal elements of pectoral and pelvic girdle. So, these are the derivatives of somatopleuric intraembryonic mesoderm. Now the next layer is splanchno-pleuric or visceral layer. Whenever we deal with the cavities, the pericardial, pleural and peritoneal cavities, we always say that it has got two layers. One is the parietal layer and the other one is visceral layer. The parietal layer will be closer to the body wall, whereas the visceral layer will be closely adhered to the organs. So the body wall layer was developed from the somatopleuric. Now let us see what are the derivatives from the splanchno-pleuric or visceral layer. So this is the splanchno-pleuric mesoderm or visceral layer, since this is lying closer to the endoderm. So what are the layers, or how is it getting differentiated? The splanchno-pleuric layer will be giving rise to the visceral layer of serous pericardial sac. Then it is also giving rise to the musculature and connective tissue of gut, respiratory tube and heart. So these are the derivatives of the splanchno-pleuric layer. As you move towards the cranial end, cranial to the precaudal plate. So once again reminding you the parts, this is the precaudal plate, this is the future neural tube, these are the somites, and this is as you look from above. If you keep the germ disc like this, and as you look from above after removing the amniotic membrane, this is the view. You can see the intraembryonic coelom formed within the intraembryonic mesoderm, and this coelom, as you move cranial to the precaudal plate, you can see that the two halves of the intraembryonic coelom are actually continuous to form the pericardial cavity. Pericardium is actually formed in this part. Now the splanchno-pleuric layer, which is seen on the floor of the pericardial cavity, it is actually giving rise to the cardiogenic area or the heart forming plate. So in the pericardial cavity, the floor is actually formed by the splanchno-pleuric layer, and it is from this layer you have the formation of heart tube. So the cardiogenic area or heart forming plate is seen in the splanchno-pleuric layer at the floor of the pericardial cavity. Now cranial to this cardiogenic area, you can get these two layers becoming continuous. The somatopleuric and splanchno-pleuric layers, they are not lying separately. If you get a tube, this tube is actually a closed tube. That means at one point the somatopleuric and splanchno-pleuric layers are actually continuous. So in the cephalic region, these two layers are becoming continuous, and that is how the septum transversum is formed. So septum transversum is actually a region in the cardiogenic area where the somatopleuric and splanchno-pleuric mesoderm are becoming continuous. And what is the fate of the septum transversum? Septum transversum is actually giving rise to a major contribution in the formation of the diaphragm. So this is a region where you get the formation of septum transversum. Now let's see the derivatives of mesoderm in a nutshell. The mesothelial linings of the cavities like pericardial cavity, pleural cavity and peritoneal cavity, all these are formed from the mesoderm. The muscles of the body, except the muscles in the eye, that is the iris, and that of the skin, the erector pili, all the muscles of the body are formed from mesoderm. Then almost all the connective tissue, the cardiovascular system, the lymphatics, the urogenital system, which includes the kidneys and the gonads, the suprarenal cortex, all these are derived from the mesoderm. And when you consider teeth, except the enamel part, the remaining part of the teeth is also formed from mesoderm. So that's all about the development of embryo from 4th week to 8th week of intrauterine period. And this is the end of part 1. We will continue with part 2 in the next session. Thank you.